All right, pre-calc, we are going to do 4.2 trig functions of acute angles. So the question of what do we remember? In this first problem, we've got a right triangle, sides 3x and 7. How would we solve for x? Hopefully you remember we're going to use a squared plus b squared is equal to c squared. It doesn't really matter what a and b are, but let's say x squared plus 3 squared is 9 is equal to c squared, which would be 49. Solve for x. X squared is equal to 40. Take the square root of both sides. Square root of 40. I can simplify that to be the square root of 4 times 10, and I can take out a 2. So my final answer would be 2 square root of 10. I know that was really quick, but it's just kind of a, hopefully you remember these things. Then the other question is, how do we name the sides of a right triangle? If this is angle theta in the corner, do you remember how we name all the sides in relation to theta? Hopefully, in your head, you're thinking, this is the hypotenuse. And, oops, did I spell that correctly? Hypotenuse. Okay, close enough. And then we've got the side opposite. And we've got the side right next to it, which is known as adjacent. I am hopeful that this first slide was really, truly review. And if it wasn't, that's okay. But these are really important things that we'll be using throughout this lesson. Right triangle definitions of trig. We're going to use that drawing we had, where this is theta, this is the opposite side, this is the adjacent side, and this is the hypotenuse. And hopefully, maybe somewhere in the depths of your mind, you're thinking, oh wait, this is SOHCAHTOA. And if you don't know what I'm talking about, don't worry, I'm going to explain it. SOHCAHTOA is a way to remember what sine, cosine, and tangent ratios are. So would be for sine. So sine of theta is equal to OH, opposite side, divided by the hypotenuse. We've talked about this before, but when you see this, please read it as sine of theta. If you say sin theta, you sound stupid, and you are not stupid. So take a moment, and we're going to write down the rest of our trig ratios. So we have sine, which is so. Then we have cosine of theta is equal to adjacent over hypotenuse. And then we have tangent of theta, TOA. Tangent of theta is equal to opposite over adjacent. These are ratios that we are using, and sorry that I didn't write out the full words of opposite and adjacent. What's really a shame about these videos is that I can't ask you the next question, but I have a feeling some of you will know. Do you remember what cosecant, secant, and cotangent are? Cotangent. If you are sitting at your computer thinking, oh, I know what those are, Ms. Gissing, those are the reciprocals of sine, cosine, and tangent, then you're right. Cosecant is 1 over sine of theta. Secant is 1 over cosine of theta. And cotangent is 1 over tangent of theta, which means we could, and I'm going to do this for one of them, and maybe not all three, I could write cosecant as the reciprocal of sine. So hypotenuse over opposite. Or I guess I can do them all because they're not that bad. Secant is the reciprocal of cosine, so it would be hypotenuse over adjacent. And cotangent is the reciprocal of tangent, which means it would be adjacent over opposite. All of this is super important, so make sure you have it clearly in your notes. The last thing I want to show you in this set of notes before we do the examples in class is two very special kinds of right triangles. The first is a 45-45-90 triangle, and the second is a 30-60-90 triangle. Maybe you remember things about them, maybe you don't, and honestly, either is okay. But hopefully, you do remember, if I have two angles that are congruent, then the sides opposite them will be congruent. So let's say this is x and this is x. If I were to try and find my last side, this would be a squared plus b squared equals c squared. So x squared plus x squared is equal to, we'll go with, let's say this is y squared, or 2x squared is equal to y squared, or y is equal to the square root of 2x squared. Hey, and I can pull an x out of there. So it's really the square root of 2 times x, which you, again, maybe remembered that this is a special kind of triangle, and it has this characteristic where if I have the side lengths, I can multiply the side length by the square root of 2 to get the hypotenuse. For our 30-60-90 triangle, sometimes known as a triangle that has like a short leg and a long leg, maybe you remember this, maybe you don't, but if I know the short side, the hypotenuse is 2 times the short side, and the long side is the square root of 3 times that short side. If you didn't remember that, please don't stress, because realistically, you're not going to be memorizing these triangles with x's. We are going to use these triangles with our trig functions. So just make sure you have this in your notes, and we will do the rest of it on Monday or Tuesday. I hope you have a great rest of your day, and I will talk to you soon.